When we look at the night sky, everything seems calm. Galaxies drift slowly. Stars move predictably. The universe appears vast, but balanced. But that stillness is an illusion, because our galaxy, the Milky Way, is moving. Not just rotating, not just expanding with space. It's traveling through the universe at over 2 million kilometers per hour. And it's not moving randomly. It's moving in a specific direction, towards something. For decades, astronomers assumed this motion was simply part of cosmic expansion. After all, the universe is expanding everywhere. But when scientists began measuring the motion of thousands of nearby galaxies, something strange appeared. They weren't just drifting apart. They were flowing, as if caught in a massive cosmic current. Galaxies across hundreds of millions of light years seemed to be moving toward the same region of space, a region we couldn't see clearly, a region hidden behind dense clouds of dust and stars from our own galaxy. This motion became known as a peculiar velocity, because it wasn't explained by expansion alone. It suggested something else was at work, something massive, something powerful enough to pull not just one galaxy, but entire clusters. Imagine standing in a river. The water around you is moving in one direction. Now, imagine noticing that not just the water near you, but water from miles away is also drifting toward a single unseen point. You can't see what's causing it, but you can feel its pull. That's what astronomers began to detect in the 1970s and 80s. A massive gravitational influence, a region so enormous that it affects the motion of over 100,000 galaxies, including ours. This mysterious region was eventually given a name, the Great Attractor. But naming it didn't explain it. In fact, it made the mystery deeper. Because when scientists looked in that direction, they found almost nothing visible, no obvious supercluster, no glowing cosmic beacon, no clear structure large enough to explain the pull. And yet, the motion remained. Our galaxy is falling towards something at incredible speed, along with an entire portion of the observable universe. So the question becomes unavoidable. What could possibly be massive enough to pull galaxies across hundreds of millions of light years? When astronomers mapped the motion of galaxies more precisely, a pattern emerged. They weren't just moving randomly through space. They were converging, flowing along invisible gravitational currents toward a specific region of the sky, near the constellation Norma. But there was a problem. That region sits behind the densest part of our own galaxy. A thick band of stars, gas, and dust blocks our view. This area is known as the Zone of Avoidance, not because nothing is there, but because we simply can't see through it easily. For years, that cosmic blind spot hid whatever was pulling us. So scientists turned to other wavelengths, X-rays, radio waves, infrared, trying to peer through the obstruction. And eventually, structures began to appear. Massive galaxy clusters, dense concentrations of matter, entire superclusters hidden behind the Milky Way. One of them, the Norma cluster, stood out immediately. It was enormous, containing hundreds of galaxies, far more massive than most nearby clusters. and it was roughly aligned with the direction of our galaxy's motion. For a while, this seemed like the answer, the mystery solved. The Great Attractor wasn't a single object, it was a massive region of clustered galaxies. But as measurements improved, something unsettling appeared, even accounting for the mass of the normal cluster, even accounting for nearby superclusters. The gravitational pull still didn't add up. There was more motion than visible mass could explain. It was as if the river was flowing faster than the rocks in the riverbed could justify, which forced scientists to consider something deeper. Maybe the Great Attractor wasn't just one cluster. Maybe it was part of something much larger. As mapping techniques improved, an even bigger structure was revealed. A supercluster so vast it spans over 500 million light-years, a region now known as the Laniakea supercluster. Our Milky Way isn't isolated. It sits inside this enormous gravitational basin, along with over 100,000 galaxies. And Laniakea itself appears to be flowing toward an even more massive region beyond, a place called the Shapley supercluster. Now, the picture became even stranger. It wasn't just our galaxy falling. It wasn't even just local clusters. Entire superclusters are drifting toward a distant gravitational center. But here's where it gets unsettling. Even the Shapley supercluster may not fully explain the motion. There are hints that the pull extends even farther, beyond what we can clearly map, beyond the structures we can confidently measure. And that raises an uncomfortable possibility. The Great Attractor might not be a single object. It might be a gravitational effect stretching across scales we barely understand. Which leads to a bigger question. Are we simply falling toward a dense region of matter? Or are we witnessing something more fundamental about the large-scale structure of the universe? Because the universe doesn't just expand. It has texture. It has currents. It has enormous cosmic filaments stretching across billions of light years. And galaxies don't just drift randomly within them. They flow, as if guided along invisible highways of gravity. So maybe the Great Attractor isn't a monster hiding in the dark. Maybe it's the natural consequence of how matter arranged itself after the Big Bang. Or maybe we still don't see the full picture. So what does this actually mean? Are we heading toward a collision? Is the Milky Way being dragged into something catastrophic? The short answer is no, at least not in the way it sounds. The Great Attractor is not a giant black hole. It's not a cosmic vacuum cleaner. It's not a singular object waiting to consume us. What we're experiencing is gravity on unimaginable scales. The universe is not evenly distributed. Matter clumps together. Galaxies form clusters. Clusters form superclusters. Superclusters connect through enormous filaments of dark matter and gas. Between those filaments are vast cosmic voids. The result is something known as the cosmic web. And inside this web, gravity flows like water downhill. Galaxies move toward denser regions over billions of years. Our galaxy is simply following the slope of space-time. We are falling, but slowly, over cosmic timescales. And here's the twist that makes this even more fascinating. The expansion of the universe is accelerating. Dark energy is pushing galaxies apart faster and faster, which means there's a cosmic tug-of-war happening. On smaller scales, gravity pulls things together. On larger scales, expansion tears things apart. The Great Attractor is powerful, but dark energy may ultimately win. In the very distant future, expansion could overpower even these enormous gravitational flows. Superclusters may never fully merge. Galaxies may never reach the regions they're currently drifting toward. In other words, the universe might be pulling us toward something that we will never actually arrive at. And that's the most unsettling part, because it reveals something deeper about the cosmos. The universe is dynamic. It is structured, it has motion and direction, but it is not centralized. There is no single center, no final destination. The Great Attractor feels ominous because it suggests a focal point, but zoom out far enough, and that focal point dissolves into something larger. Every region of space is part of a greater gravitational pattern, and every structure is nested inside something even bigger. We are not being pulled toward doom. We are part of an enormous, flowing cosmic system. A system shaped by gravity, dark matter, and the initial conditions of the early universe. The motion of our galaxy is not a sign of danger. It's a reminder that even on the largest scales imaginable, the universe is not static. It moves, it evolves, it rearranges itself over billions of years, and we are inside that motion. Right now, the Milky Way continues its journey, 2 million kilometers per hour, toward a region of space we cannot fully see, pulled by forces spread across hundreds of millions of light years. And yet, in the grandest sense, there is nowhere to arrive, only the ongoing dance of gravity and expansion. The universe isn't collapsing, it isn't targeting us, but it is flowing, and we are flowing with it.